Have you guys taken the test yet?
I took it yesterday.
Yeah, I'm taking it today.
Hopefully I'm taking it tomorrow. I didn't even get the preparation assignment finished today because Haley wouldn't go down for a nap. So
Yeah, I always try to do 11, and there was like when you have to solve it by yourself without the program, I was like, oh, if the standard deviation wasn't the same.
Yeah.
I did all the lessons though, so the readings.
Yeah.
I should be
Yeah.
good.
Same here. So we'll find that out when we take the quizzes.
Yeah.
Yeah. It's so much more difficult with a baby to do schoolwork.
I'm sure.
Because your life
Yeah.
like revolves around them.
Mm-hmm.
And if they don't take a nap, you don't do schoolwork.
Yeah, my sister was a couple semesters ago was taking some online classes, and she has 3 kids, and she had a full-time job, and it was crazy.
Oh man, I can't imagine working. I'm a stay-at-home mom, so I'm very blessed in that regard.
Mm-hmm.
Yeah.
Well,
Okay.
are we ready to do the quiz?
Mm-hmm.
Sounds good.
Making sure you're ready.
I'm ready.
You're the one with the baby.
Yeah.
Okay, I guess we'll get started then. Okay, first question says, find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample size is 25. Okay, what'd you guys get for this one?
Trying to remember back. Just to make sure I'm doing this right.
So it's
You
like,
take the standard deviation and you multiply it by the the population standard deviation divided by the square root of the 25, right?
is just the what's it called now? There's a section of the notes where it talks about level of confidence, and then it's like 90%. That would be like 0.1, so it's 90%. I don't know. I thought it was like, I know it's 50 divided by square root of 25,
Right, so it's 50 divided by 20, the square root of 25, right?
Yeah.
It's 10. And then you multiply that by the 1.645, which is the
Yeah, that's what I got.
90%. Okay.
So it came out to be 16.1, or 16.45.
Okay, that's what I got.
I'm not sure if that's correct or not. It says round to 3 decimal places.
Let me make sure I put in the right numbers this time.
Because they didn't give us a mean or anything to.
Yeah, they didn't. Well, margin of error, there was a specific.
Yeah, equation for that.
Yeah, so I'm guessing it's that. But there isn't a third decimal, so we might as well just put 16.45.
Yeah, I got that answered too.
Cool.
Sounds good.
Helps when you put in the numbers correctly and not the decimal in the wrong spot.
Yeah, right. Those simple
That's
mistakes
true.
always suck. All right, so which of the following statements are true? Mu squared is an interval estimator of the mean. The mean is a point estimator of mu. Mu is a point estimator of the mean. And then sigma is the interval estimator of sigma squared. I thought the mean was a point estimator of
the X bar?
Yeah, standard deviation.
I think it might be the second one. X bar is a point estimator of mu.
Okay, that's what I think so too.
Okay.
Maybe. Did it go?
Good thing got 2 chances on it, so.
Yeah.
Okay. Next one. It says Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample size of 64 and computes X bar to be 526 for the next 6 questions. What is the point estimate for the true GMAT score?
Wasn't that 560 or 526?
Yeah. Then what is the margin of error for 95% confidence interval?
That was 1.96 for the
For 95, yeah.
Z-score, right? Okay.
So take 113 divided by square root of 64. What'd you guys get?
I'm still working on it real fast. I did something wrong. So the first number was 498.315, right?
Did you just do 113 divided by the square root of 64? Is that what you did? Because I got 14.125.
Margin of error. This is. There's so many equations.
Mhm. It's like the very first question we did. Pretty sure. Yeah.
Just using different numbers.
Mhm.
Oh, I see. I was thinking of something else. Haley. So it was 113 divided by the square root of 64.
And then multiply it by the 1.96 since it's a 95% confidence level.
Okay. So that was 54.2626.
Yep. Wait, no.
That's what I got.
I got 27.685.
Oh. I already did that when I got 27. Man, it'd be so much easier without Haley. $685.
Yeah.
Okay.
That's not going to sit around or anything, but just put everything. The next one
All right.
says the lower limit of this confidence interval. So we take the answer we just got for 6. And
Subtract it
yeah, we
from the 113.
Oh, okay.
The
not
512.
the 5.
The 526.
Yeah.
Subtract from 26.
Yeah.
Okay, that was the answer I got
That
before.
was the answer you had the first time. Yeah.
498.315. Jumping again here.
You got it right though.
Yeah. Phew.
Same thing for the next one. Instead of subtracting, we add it.
I got 553.685.
Yep.
Cool.
Sweet. Okay. It says what would happen to the width of the confidence interval if Gina increased the sample size?
It would. Can't remember. Did it decrease?
I think it will, because like the more you have, the closer it gets to that
Right.
bell
Okay.
curve.
I was thinking the central limit theorem, right?
Mm-hmm.
So yeah, it would decrease.
Okay. What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval?
It becomes wider.
Yeah.
Mm-hmm.
So it would increase. So it increases.
Yep. Okay. Next one says bright bulb light bulb company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours, percent confidence interval with a margin of error of 50 hours. What sample size do they need? This is one that they're working backwards.
Mhm.
That was the n equals. You time the. Okay, I'm just gonna do it. I think I got it though.
Okay.
Normally I review before I do this, but
So many adults had plans.
yeah.
I remember like last Tuesday, like my internet went out like, when I was trying to study, and I was like, okay, whatever.
Isn't it great when that happens? Oh, this is the one where you round up, right?
Mhm.
Yeah.
2-4. So, are you guys done?
I got 64. Is that what you guys got? I did something wrong.
I got 246.
Isn't this one just 50 equals 400 divided by the square root of x? Well, n.
It
So
was well, there was a specific formula for it. It was n equals the z-score times the standard deviation divided by the margin of error, and then you times that by the you square it. That's what I meant to say.
oh, that's right.
So it was
Yeah.
1.96 times 400,
Times 400 over
and
the
then
square root of n equals 50.
no, it's actually you just divide it by 50. M is not square rooted. And then you square that, the final answer from that.
And 254.86. So 256? Or 246?
I got 246.
Awesome.
Is that what you got?
Yeah.
Yeah.
Okay. All right. The mean salary of actuaries is mu equals 100,000. And the standard deviation is $36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of significance 0.05 and the null hypothesis of 100,000. The alternate hypothesis does not equal 100,000. You collect a simple random sample of n equals 36 women salaries and find that the mean is 111,000. What is the lower limit of this 95,000 confidence interval?
So we take 111,000 minus the 1.96 times 336,730 divided by square root of 16. That's 36, right?
Wait, I got lost.
So find the margin of error that we did, and then we have to
Subtract that from 111,000.
Oh, okay. Sit down.
What did you guys get?
I got the margin of error is 36 to 60.
I got 98,756.
No, I just redid it and I got a different answer. Try it again.
Because we did the margin of error, which is 36,730 divided by the square root of n, which is 36.
Yeah,
And that is
that's 6,121.
great. And then you take that,
And we multiply it.
multiply it by 2. That is 95% confidence. And then you take that number and subtract it from 111,000.
Where did you get the 2?
So 95%, remember that's the 2 standard deviations, right? In between all that is 95%. 95% confidence, which is in those 2 standard deviations. So you find the 1 standard deviation, but you have to multiply it by 2. You have the 2 standard deviations. Does that make sense?
Yeah.
Yeah. That's 8. I got 18,130. What?
I don't need to subtract it from the lower limit. I got 98,758.
Right, I'm gonna do it again just to make sure I get it right.
Yeah, I got it. For the lower limit, 92,870.
Okay, so the standard deviation multiplied by 2 should be 12,243.
Yeah.
And then you take 111,000 minus 12,243.3, which equals 98,756.667.
Surrounded 57 at the end. Awesome.
Is that what you got, Becca?
I'm not sure what I got wrong because I don't know. So what did you get?
We
The
got
lower?
98,757.
Okay.
Because you have to subtract it from the 111,000.
Mm-hmm.
You probably mixed something up in the standard deviation.
Yeah, I probably did. That's what it looks like.
Yeah.
So it's 9. The lower one was 9.
98757.
Okay. It got something close to that somehow, but not that.
Yeah.
That's all right.
Like, got one number, 2 numbers that are different, but very close to that.
Yeah.
And the upper limit.
um,
123,244.
that's what I got.
Okay, last question. Says there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are, I think all of those are right.
Yeah, simple random sample. Sigma is
On the
known.
population, sigma's no. That's
Normally
what you're
distributed.
solving.
Yeah.
Lesson.
It's really the only one we could pick too, because we can't pick multiple.
Mm-hmm.
Okay. Let's see how we did.
Cool. Oh,
Up. Looks
12
like we
and
missed
13.
12 and 13. Yeah.
Mm-hmm.
We were all wrong.
Maybe those are the numbers I got the first time when I did it
Really?
with multiplying by 1.96 instead of multiplying by 2. So maybe when we weren't supposed to
Oh.
multiply by.
Yeah. That was my bad.
No, it's all good. I actually thought you were right on that one because I remember talking about that in the notes.
What did you guys get on number 4?
Number 4 was the second one. X bar is a point estimator of mu.
Oh.
Go back and change that later.
So it was 36,730. Oh, maybe I should
Yeah. Divided by 36, and then instead of multiplying it by 2, we still multiply by 1.96.
Oh.
Small small margin of error there, but
So 6,121.66.
For 12?
yeah, for 12s and 13,
So
we were supposed to multiply it by 1.96 instead of 2.
Oh, okay. That's like a very, very small difference.
I know, yeah, it's only by 0.04, but it
Wow. Okay.
messed it up.
Yeah.
so what is the number we subtract and add by?
So we subtract 11,998.46, and that goes on forever. And I got 9901 or 002. Okay.
9901.
Sorry, 99002. I said that wrong.
Yeah, because it says round to nearest whole number. Yeah.
Or the lower limit?
Yeah, that was the lower limit.
Yeah, that was the lower limit. 99002.
And then the upper limit.
Upper limit came out to be 122,998.
Yeah, that's what I got. All right. Note taken.
Don't follow the textbook. Because yeah, I remember reading about that.
I was
like, oh,
looking
yeah,
at it
that's
as I was
right.
doing it. Yeah, interesting. Well, I guess we can go change that after.
Yeah.
Or do you want to change it now? We can.
We've got time. Do really fast, and then we'll start the next one.
Mm-hmm. So let's do homework too.
Yeah, that's right. She kept grabbing at my headphones. I finally had to put her down. Babies. I love them.
Okay. Resubmit.
All right, I'm good on that quiz.
Me too.
Awesome. I'm pulling up the next one.
Mm-hmm.
Okay, it's loaded.
Oh, cool. Now I get to use the other distribution chart.
You know, I was looking for this one, this other
I-
outlet, and I couldn't find it.
Same. I was shocked.
Yeah, so it's in the actual reading, which is in a really hidden spot. It took me a while.
I was like, I was looking
find
for it. I was just like, I can't find it.
It's so in the first little segment that you read underneath 2, what if we don't know the standard deviation?
Uh-huh.
In the last paragraph before all the graphs or the
Oh, yeah, I see it now.
distribution things, it said click here to explore. So it took
Yeah,
me a
because I was
while.
doing the homework, and I was just like, well, I don't know how to pull that thing up, but whatever.
Yeah. Same. I'm like, what am I doing here?
Oh, well, now I have it, so
Now
it
this
works.
makes a lot more sense for that homework quiz because I did the homework quiz yesterday too.
Oh, I
And
haven't
we
done
kept
that. I
getting,
normally do
I was
that
having
after.
my dad help me because he loves math and everything. He loves learning and everything. So I'm like, we kept getting a few wrong. We're like, okay, how do we figure this out again? But that makes so much more sense now. There's an actual theme.
Yeah, it's actually really easy with it. It's great.
Good.
Not that I did much with it because I didn't finish everything, but all right.
Sounds good.
So question 3.
In our previous lessons, we had assumed that the population standard deviation was known. In this lesson, we're making a different assumption about the standard deviation. What has changed? It's unknown.
Yeah.
Makes sense.
All right, for the next 2 questions, let the null and alternative hypothesis be mu equals h and alternative mu is greater than 8. Okay, AC. Sorry. Assume that the population standard deviation is not known. Becca collects a sample of size n equals 9 and computes. The mean equals 11 and S equals 9 or 6. Man, I'm getting all this mixed up.
Okay.
So is the standard deviation known?
No. What is the
What is
t
the value
value?
of t?
This is the one. I worked it out.
That was
on the homework, and I was like getting a different answer than what it said. So hopefully it goes right this time.
Yeah.
It's 11 minus 8 divided by s divided by the square root of 9, right? Oh, 6 divided by the square root of 9.
So it's 3 divided by 2, which is
1.5.
1.5.
Yep.
I think I got it right. At least I got the same one you did.
Yeah.
All right.
Yeah.
This one says use the body temp
Yeah.
in the software.
Oh, where did it go? Search for these.
Use 98.6 as the null hypothesis.
What sheet was it?
That's the body temp.
I know, but the
Oh,
software.
the other one, it's the quantitative inference procedures.
That's in the Excel help tools.
Mhm.
I just figured that out. I've been looking for that the whole time. All right.
I know that's like everything that we need for the units.
Mhm.
All right, so you copy and paste all this in Neat. Can you not copy and paste on the...
From the quiz? No.
Really? Interesting. Well, that's nice to know. But oh, it does say to get it from there. It's just a short list in here.
What is...
Why did they? It says copy and paste them into your software.
Yeah, but it won't let you copy and paste from the thing.
So you
Yeah,
have to
why?
do it from the actual template.
Yeah.
But this is only a small portion of the template, so
Yeah.
I really don't want to have to type that all in.
Use the following values which are pulled out. So I guess you just have to type them in.
of
Because
course.
it's not the whole list.
Yeah.
I
I'm
think
right
that was a flaw on their part.
Mm-hmm.
Dang it. Okay.
Because I've
It might
had.
take a while.
Mm-hmm. I'm writing them all down otherwise.
Whenever I do this, I feel like I'm going to put in something wrong.
Yes. I will do that. It's almost guaranteed. Where am I?
Oh, I had this printed down. I was like, what number did I stop on?
Mm-hmm.
And the mu is less than, right?
Mu is less than.
And a level of significance of 0.05. Okay. Did you put that in somewhere? I can't remember.
Which one?
The level of
The
significance?
level of significance? No,
You
that's just
convert
risk
it.
needed for
Oh, okay.
needed if we need to when we decide to reject or accept the hypothesis.
All right. So the mean I got is 98.220.
Yeah, that's what I got.
Are you good, Becca? I don't want to go ahead.
I'm still putting them in.
Okay.
Okay,
Wait.
well, wait.
I'm sorry.
No, you're fine.
Glad they didn't have us put all the 180 something.
Well, that one we can copy and paste. That's easy.
Oh, true.
I was putting my finger under each number so I'd know where I was.
Mhm.
That way I wouldn't get it wrong.
Yeah. But when there's a large group of numbers like this, my dyslexic brain goes haywire. So there was
It was 20 items.
there's 20 numbers put in. Okay. And it helps if I have less than. Okay. And what are we doing? The mean, right?
Yep.
98.28.
Another sample.
No.
I got 98.22.
Okay.
Do you want us to read the numbers?
I don't think. Let's see. Maybe if I go through my list and then right here. Sure. So it was
So it was 98,
Mhm.
99.6,
aha.
97.
Hold on.
Okay.
I got one problem already. 99.6.
Yes.
Okay. The third one was
97.8.
okay.
And then we've got 97.6,
Okay.
98.7,
Okay.
98.4,
Mhm.
98.9,
Okay.
97.1,
Okay.
99.2,
Okay.
97.4,
Yep.
99.1,
Okay.
96.9, 98.8,
Okay.
99.9,
Okay.
96.8,
Okay.
97,
Mhm.
98.7,
Okay.
97.6,
Aha. Here's another one. 97. Okay.
so 97.6, and then
Yep.
there's 98.7,
Okay.
98.2.
Okay. Yep. Now I have it. The 98.22.
Awesome.
Awesome. All right, and then S, standard deviation, I got 0.922.
Mm-hmm.
Yep, sounds good.
Is that what S is?
Yeah, it's the
Okay,
sample
just wanna make
standard
sure.
deviation. I know there's so many variables, but they're all like the
I
same
know.
term, just for different things. If it's either population or sample,
Yeah.
that's what throws me
All right,
off because I see it in my physics.
T-score.
T-score would be
Yeah.
T.
Negative 1.843,
Yeah.
and then p-value is 0.040.
Hold on. How do we use the little applet
No,
thingy? Or
it's
something
already
else?
in the it's in the Excel
Yeah.
spreadsheet.
Everything is in the one sample t-test for means,
Okay.
Excel.
Where did you find that number?
So T,
Mm-hmm.
do you see where N is?
Yeah.
It's right below that.
Okay.
And then the p-value is 2 boxes to the right.
Okay.
And then the standard deviation is above the p-value.
Yes. But no, for the T, what did you get?
The T, I got negative 1.843.
Okay, because my T does not show that. So I'm trying to figure out.
Oh, it's
Oh,
probably because. Yeah, go
did
ahead.
you change the null hypothesis in the second box?
Nope.
Yeah.
I changed it to the 98.6.
Yep.
Mhm.
And then type of test would be less than.
Okay, yeah, I changed that one. So 98.6, right?
Yep.
Yep.
Okay, there it goes.
All right. And then it is less than 0.505. So we reject it, right? The p-value.
If it's greater than, we fail to reject it. If it's less than, we reject it.
Okay.
The p-value you got 0.04, right?
0.040. Yeah.
And we failed to reject.
We
We
reject it.
Reject.
Yeah.
Yeah.
Why do they make it so confusing? Do you reject it or you not reject it? Why fail to reject?
Well, it's right below the 0.05 threshold.
Yeah, I know.
I don't
Wow.
understand why they don't use accept or deny or accept.
Yeah, exactly.
I
That's what I'm
know.
trying to figure out. Accept or deny, please.
You can't, though, I guess, because that's what they taught us in the science class. You cannot accept a theory because you can be proven wrong eventually.
Yeah.
Mhm.
It's weird.
Yes, it's very weird. Oh well.
All right. Well, next one.
Oh,
Use the following values, which were pulled from the data file Baby Boom, JSE, for the next 6 questions. These values are the wait time in minutes between birth at a hospital. Copy and paste them into your SPSS. This is wrong.
okay, again.
So the hospital claimed that the average time between births is 40 minutes and plans its resource allocation based on its claim. You want to test their claim.
More numbers to put in. Yippee.
Woohoo.
See how well this goes.
There we go.
There were 21 values?
Yeah.
Okay. Pretty sure I got it right then. Okay, just to make sure, I got a p-value of 0.995.
Yeah, that's what I got.
Okay. I got all the numbers right.
Um,
Oh, so it says, please enter either the data or summary statistics, not both. I wonder if we didn't enter the data and we put the statistics in, it would work, except we don't have those.
You just leave the
Did we have
summary
it for the first
statistics alone, the mean, standard deviation, and the confidence level and null hypothesis you can change.
Yeah.
Is that
I was thinking if they gave that information, we could put that in instead of putting the list in, but they didn't.
Yeah.
So. My good idea was squashed. That's okay though.
and a type of hypothesis is not equal to this time?
yeah.
Yep.
I got 20 numbers.
Do you want me to read them again?
Yes, please. Sorry.
No, you're fine. Okay. So I got 59,
Okay.
12,
Okay.
37,
Mm-hmm.
62,
Okay.
68,
Okay.
2,
Mm-hmm.
15,
Okay.
9,
Okay.
157,
Mm-hmm.
27,
Okay.
37,
Okay.
2,
Mm-hmm.
55,
Okay.
86,
Okay.
14,
Okay.
4,
Okay.
40, 36,
Okay.
47,
Okay.
9,
Okay.
and 61.
Uh-huh. There we go. I just skipped over some numbers. Skipped over a number. Of course.
Okay, so yeah, for the p-value was 0.995.
Mm-hmm.
Got that now.
And then if you would fail to reject it,
Okay.
Because it's greater than. Yep.
Mm-hmm.
all right, and then you decide to try another alternative hypothesis. This time you use it's greater than 40,
Okay.
and you keep the same level of significance. Did the p-value increase or decrease? it decreased.
When you make it less than, let me change it. real
Yeah,
fast.
less than. Went down to 0.49.
So that's a decrease. Okay.
So what decision do you make? That would be fail to reject again, right?
Still failed to reject, yeah.
All right.
The
Okay.
p-value decreased or increased?
It decreased.
Decreased.
It went from 0.9 to 0.4.
To 0.4, yeah.
Okay. I did something I messed up. Yeah. Okay. I messed up my Excel page, so I had to go and undo a bunch of stuff to make sure I didn't mess it up again.
It's all good.
So this one cell selected, and then I tried to do something else, and it went all haywire again. Just my luck. Oh well. Okay.
That's all right.
Now construct a 95% confidence interval for the true mean wait time between bursts.
So it's at 95.
Mm-hmm.
What is the lower limit?
Mm-hmm. And it's
It was 20. It's
23.5.
23.37.
I got 23.49, and then it says round to 1.
I have 21.561.
In the spreadsheet?
Mm-hmm.
You kept the null hypothesis
Oh.
at
40.
you keep it at 40?
Mm-hmm.
Yeah. Okay. I didn't touch anything besides confidence level. 0.95.
Mm-hmm.
I think I put a number in wrong. And after fixing it, I have 23.49.
Okay. So it rounds up to 23.5. And then upper limit is 56.6.
Okay.
Let's see how we did. Okay, got everything right.
Yep.
Awesome. Okay. I'll send out the link for this in a few minutes, and hopefully the last I checked, like you were the discussion board thingy where we should put the links is not showing up again for lesson 9.
Mm.
You might just have to email it to him.
Yeah, so we'll do that today
Sounds
too.
good. I think, could you put our names on the discussion board last time? He asked that we put
No.
the names of those
Yeah.
who participated, even though
Mhm.
we're already all there. So.
Mhm. Yeah, I'll add it this time. I'm like, I'm not gonna. Like, now that he added that comment, I'll go. From now on, I will. But I'm like, really? You should be able to figure out who's there and not there.
Yeah, but Whatever. It's all good.
Yeah.
Because it says you spot check the little videos. I'm like, this is saying you are not doing that.
It's like already in the quiz too. It's like, did you participate? Yes or no?
Oh well. So I'll do that.
Yep.